Hello everyone, today we are going to talk about our project 3. Our project 3 has two parts. The first part is real estate analytics and prediction, and the second part is deep learning model for financial data. Here comes to our first part, real estate analytics. In this project, we are mainly focusing on how to predict whether a house is buyable or not. To define it as buyable or not, it means that if a house can be sold within 3 months after it was posted online, then it's buyable, and if not, it's non-buyable. The reason why we want to focus on this project is because in recent years, online real estate websites are becoming an important platform for people in US to sell or buy apartment. In that case, we are interested in exploring factors that can influence the popularity of an apartment on market. So we first explore our data, and then we build machine learning models to predict whether the apartment or house is buyable or non-buyable. The data we got are retrieved from the websites. The first one is apartment and house information website crowded from realtor.com, which is one of the biggest real estate transaction information website in US. And the second dataset is about the crime index in New York City. It's manually added based on the information on best places. We combine these two datasets together to do our final model and prediction. Considering people in different regions have different patterns and preference on purchasing house. So in that project, we mainly focus on real estate transactions in New York and Berkeley. After we crowd and retrieve the data from all the websites, we started to do the data processing. The first problem is that there are a lot of data, text data instead of numbers, such as the information of the schools nearby and the location and the school rating. So the first step we do is to transform those text data into numeric data. And there are also a lot of missing values in our data set. So we replace the missing values based on each column, and we use different methods to replace them. And after we got two clean data sets, we merge this data together by zip code to do our final prediction. We also do resampling on the data set by small e because of the reality that most of the house and apartment can be sold within 3 months. So the data is quite imbalanced. The original data, the majority ratio is 60%, and then after resampling, it becomes 50-50. Then we split the data set. We split the data into 60% training, 20% validation, and 20% testing data. Before we do the prediction, we want to have a general idea of our data set, so we did some visualization. The first one is to do the visualization with the map information. And the blue part is school rank and the purple part is crime. We can see that they have quite different patterns on distribution in New York City. For the school rank, we can see that the higher school rank here is in Tribeca. And for the crime rank, we can see that most of the places with higher school rank have lower crime rate. Here is the result of the target and crime. The target is a binary target, which means whether the house is buyable or not, and here is the average value of target and crime. We can see that they actually have a quite similar pattern compared to the previous one. And next one is the relationship between crime level, price, and days until sold. We can see that actually this three data set doesn't have strong correlation with each other. And here is the heat map of our data. We can see that most of the data are not highly correlated with each other. Then we visualized our data set with different dimension reduction method. Here we used kernel PCA, KPCA, t-SNE, and LLE. However, we found that none of this method can distinguish our target pretty well. So we here come to our prediction model. Here is the prediction model with the data of real estate information but without crime index. And we use three different machine learning models: extra tree, DNN, and the Grande Boost. Here we can see that the best performance model is extra tree, and Grande Boost actually have a really bad performance on this prediction. And the right part is the ROC curve of the three method, and on both data set. And the next prediction is the result of the same machine learning methods, but on the data with the crime index in it. We can see that the result enhanced slightly, especially the result of DNN. Actually, DNN didn't perform well on the first dataset, but it actually performed pretty well on the dataset after adding crime index. After do the model prediction, we start to evaluate our models. Here we applied 5-4 cross-validation on the two dataset and on the three machine learning method. We can see that the extra tree is the most stable method in this three method, and the Grande Boost had really severe overfitting issues. Finally, we decide extra tree as our best performance model in without crime data, and for the with crime data, actually DNN is the best performance data. And for the limitation, because our data set is pretty small, only with more than 700 data, so the accuracy may be different when the size of the data increase. And we can also see from the result after adding crime index into the data set, most of the result was increased, and the overfitting issues was decreased. After building our model, we decided to use the result to build a mini AI system. And the right part is our methodology of this AI system. In this AI system, we are aiming at enhance the efficiency of finding desirable house for customers. After utilizing this system in house searching, the customers are able to filter the non-buyable house and find house meet their expectation. And here we choose the extra tree for our final prediction. Even though DNN had a better performance than extra tree, but extra tree is more stable than DNN. Here is an example of our mini AI system. If you input your budget and the bedroom number you want. Here you can see the result of the AI system recommendation.